Number 14. Okay, for this problem, the process is really obvious. Okay, and first of all, we're going to find eigenvalue. Then we're going to find like corresponding eigenvector. Then we're going to find psi matrix, which consists with a fundamental set of solution. And then we're gonna find pi matrix, which is fundamental matrix. Then you can find the solution. Okay, that's it. Okay, so let me start from eigenvalue. Here we go. To find eigenvalue, we have to set the determinant of a minus lambda I equals 0. Okay, so my a minus lambda I is, okay, this determinant minus 1 minus lambda negative 4 1 and negative 1 minus lambda. Okay, let me do the to the right side. Okay, it is AD minus BC, right? Negative 1 minus lambda square and plus 4 equals 0. To the distribution, 1 plus 2 lambda square plus 4 equals 0. In order, lambda square 2 lambda plus 5 equals 0. Okay, so like this one, we have to use the quadratic formula. Then my lambda is minus b plus a minus square root of b squared minus 4ac, which is 20, over 2, which is negative 2, plus a minus square root of negative 16, which is 4i over 2, then is negative 1 plus a minus 2i. Okay, so we have like two different complex number, negative 1 plus 2i and negative 1 minus 2i. Okay, as we discussed about this one in the previous section, and you don't have to worry about like both of them. Okay, and with only one of them, and you can have the fundamental set of solution. Okay, so we're going to use negative 1 plus 2i. Okay, okay, we will work on eigenvector. To find eigenvector, we have to do a minus lambda I v equal to 0. Okay, what is my a minus lambda I vector? I mean a minus lambda I matrix. It is negative 1 minus 1 plus 2i and negative 4, 1 minus 1 plus 2i. And vector b is v1 and v2 and 0 vector. Okay, let me simplify my matrix. Okay, minus 1 is gone and it is 2i, negative 4 and 1 and negative 2i, right? And negative 2i and v1 v2 equal to 0 and 0, right? But keep that in mind, with the first row or second row doesn't matter. Okay, you can have like same value. Okay, so like for my convenience, let me choose the second row. Okay, it doesn't matter. Okay, they are same. Okay, the final answer will be same to each other. Trust me. Okay, you can practice both of them, but like again, your result will be same. Okay, let me choose second row because it's much simpler. Then v1 minus 2i v2 equal to 0. Then move your v2 term to the right hand side. Then I can say your v1 is 2i v2. Then if I choose like v2 as 1, my v1 is 2i, right? So my first eigenvector is equal to 2i and 1. Okay, let me decompose this one into the a and b vector, I mean real part and imaginary part, and 0, 1, and I times 2, 0, right? So let me say this is A and this is B vector, okay? Then what are you gonna do? And as you discussed about in the previous section, so then we can find the fundamental set of solutions, okay? So let's say it's U1, U1 t is equal to my real part of eigenvalue is negative 1, which is e to the minus t and vector A, which is 0, 1 times cosine imaginary part 2t, right? 2i, which is 2t, minus vector B and sine 2t, right? So let me move a little bit down. Then I can write this vector on the side. That is equal to, let's see, negative 2 e to the minus t sine 2t. And your second row is e to the minus t times cosine 2t. That is like first fundamental set of solution, okay? And then what about u2? u2t can be found like a similar way, for e to the minus t and a sine 2t plus, this case 2 plus, right? b cosine 2t. We discussed about this technique in a previous section, okay? And then that is equal to 2 e to the minus t cosine 2t and e to the minus t sine 2t, right? So like you can check the Wronskian of these two, and definitely your Wronskian is not equal to 0, okay? So we can say these are the fundamental set of solutions because it's 2 by 2, that's enough, right? Then now we can set the fundamental matrix psi. Here we go. Then my psi matrix is equal to, just combine the one, right? u1 and u2, which is negative 2 e to the minus t sine 2t e to the minus t cosine 2t and 2 e to the minus t cosine 2t and e to the minus t sine 2t, right? And now we're going to plug in 0, okay? Psi 0 is, all the exponential part is 1, and sine is 0 and cosine is 1, right? Then it is 0, 1, no, 2, and 1 and 0. This is psi 0, okay? Then we need like psi 0 inverse, right? Psi 0 inverse, which is 1 over determinant AD 0 minus BC, okay? And then switch and opposite, which is equal to 0, 1, 1/2, and 0. That's it. We are almost ready, okay? So I think we need a little bit more space. Let me make it a little bit smaller. Okay, let's do it. Where is it? Okay, here we go. So now we have to set up the pi. Which is equal to psi t times psi 0 inverse, right? So which is psi t was negative 2 e to the minus t sine 2t, 2 e to the minus t cosine 2t, and e to the minus t cosine 2t, e to the minus t sine 2t times 0, 1, 1/2, and 0, okay? And that is equal to 0 and 1/2, which is e to the minus t cosine 2t, and 1 and 0, which is -2 e to the minus t sine 2t, and 0 and 1/2, 1/2 e to the minus t sine 2t, and e to the minus t cosine 2t. Are you with me so far? It looks a little bit complicated, but like it's doable, right? So like, we are ready. Now we set up the fundamental matrix, like for the initial value problem, then your solution is pi t times the initial value. That's it, which is e to the minus t e to the minus t cosine 2t minus 2 e to the minus t sine 2t 1/2 e to the minus t sine 2t e to the minus t cosine 2t, and my initial value, what was it? It's 3, 1, right? Okay, that's it. Okay, when you multiply this one, it is equal to 3 e to the minus t cosine 2t and minus 2 e to the minus t sine 2t, and 3/2 e to the minus t sine 2t plus e to the minus t cosine 2t. This is the solution of this initial value problem. Okay.